check in, you can use this QR code to check in too. So I'll give you a, like, 10 seconds to scan it. Some of you already did your homework. Very good. Well, I guess if you missed too, don't worry. I'll share it with you too. So later. All good. Oh, really? Just click it. Oh, okay, okay. Yeah, yeah. Okay, that's cool. Well, anyway, this is from Bill. So yeah, he got this slide deck ready. So okay, some what is sharing on this Zoom? It's clicking on. So what would I do? I'm just sharing it this way. Is full screen? Yes. Okay. All right. Okay. All right. Some housekeeping. Who is AI Camp? We're a global AI developers community with 500,000 and more AI developers in 150 plus countries. We empower every developers to learn and practice AI from everywhere at any time. And there are plenty of local community chapters in 50 plus cities in 15 plus countries. So these are just a handful of all those cities too. So we are on there in North America. So. And how do you get involved? You can join Community Builders team. We plan and host events and grow the community in Chicago. You can also submit topics to speak and also sponsor the meetups. And that's what we need the most, as somebody who can sponsor our venue. And again, thank you so much to Microsoft, to David Giard, although he's somewhere, he's in the front. If you see him, tell him thank you. He's been really a great community partner. Also, thank you for the food and drink. I think this time is AI Camp. Bill funded it, and also prizes. Today, we don't have enough funding for prizes. Well, he didn't tell me, so sorry about that. And if you want to get a hold of the organization, this is the email address, info@aicamp.ai. We have weekly virtual events. Currently, there are Gen AI and LLMs webinars with Google on April 17th, tomorrow, and also next week, the 25th. And there are the next in-person meetup in Chicago will be May 7th, and also again here will be here at Microsoft. If you want to go to aicamp.ai, you can find out all sorts of events listed there too. And we have our community on Discord, and if you want to join, that's the QR code. We encourage speakers and attendees to come together and learn and share materials and study groups. Startups, if you have innovators, collaborators, founders, you're welcome to join our Discord channel. And there are career openings and resumes and hiring managers. So it's really a very vibrant community. And again, we want to thank our partners and sponsors. Today, there's Microsoft for the venue, and Matillion sending Angus here for the talk, and Vectorize sending Chris and to be here. So just a word too about Chris and I. Actually, I worked for Chris too. So when he told me on Monday, I think he said, "You're coming." I said, "Really?" So I'm going to host you. So here I am. So I'm very glad to have Chris from Denver, and I think Angus came from Wisconsin, right? So thank you for these two out-of-town speakers. Again, these are our two speakers, Angus Kinsey and Chris Latimer. So that's all. So yeah, so the stage is all yours, and we'll have Angus to come first. Thank you.
How's it going, everyone? My name is Alex. I'm an account executive with Matillion. We have actually decided to make it a little more exciting tonight, and so we've got a Connor Bedard jersey that we'll give away at the end of the night. So there's a QR code that should come up on the screen if you're a hockey fan. If not, maybe someone you know is. Um, excited to be here. Thank you, AI Camp, Microsoft, for letting us put this on. Um, excited for you all to learn a little bit more about Matillion, how we empower a lot of our customers to do more with their data. But with that, I'll hand it over to the real magician here with Angus.
This thing on. I speak like this, can everyone hear me? Quiet. But no split. Gotta bring you to all my presentations. Stephen. Is that better? Okay, great. Okay. Well, maybe I'll hold it. So great to see you all today. I know some of you are still scanning that QR code, so I'll leave that up here for a moment while I introduce myself. I'm Angus. Yep. Yep. All right. Thumbs up. Cool. So my name is Angus Kinsey. I'm an enterprise solutions architect with Matillion, and I'm here to talk to you about Matillion and how we integrate with AI and leverage AI in order to increase the productivity of data engineers and data professionals. As an agenda for the talk today, I'm going to walk through a quick intro to Matillion, kind of just familiarize with the general concepts, what we do, what we're great at. And then we will dive into how we're leveraging AI from two perspectives. One, AI in the product, and as you can see there, AI in the pipeline. And I'll explain a bit more what those mean in a moment. Before I go any farther, yep, we lost the Zoom. Alrighty, we'll try again. Did I hit stop sharing automatically for some reason? Okay. We good now? Lovely. Cool. By a quick show of hands, who here is familiar with Matillion before today? Couple people, maybe the Matillioners in the room. So ultimately, Matillion is a cloud ELT platform. We are purpose-built for the cloud data warehouse. We work in tight partnership with Snowflake, with Databricks, with Redshift, with Synapse as well. And yeah, cloud ELT is the name of the game for us. So we generally have identified a high-level challenge that demand for data is ever increasing. More people want data, they need it fast, and data professionals as a result are under a lot of pressure to very quickly build out new data pipelines, move data from place to place, and get real value-add analytics out of it. A few stats up there, all of them kind of just speak to the fact that we've got a high demand for data, and we need to be able to work through that backlog of data requests as quickly and efficiently as possible. So that's the challenge we've identified. Enter Matillion, the productivity platform for data teams. We the work of building data pipelines extremely productive and repeatable, and allow you to very quickly and easily build via our low-code platform pipelines for replication, for transformation, for leveraging AI as well, as we'll see in a moment. Just continuing to give a bit more background on Matillion. So if I haven't said this yet in this exact wording, we think of ourselves as an end-to-end ELT platform. So some utilities on the market out there do a portion of the puzzle. They help you replicate data, they may help you transform it, they may have some AI integration, or they may be an AI integration, but we do all of the above. We help you to, and I'm going to speak mostly in the context of Snowflake today. So let's just say we help you to move data from anywhere into Snowflake. Noticing that we lost the share. I'll try to fiddle with a cable over here. to get any type of data into Snowflake, whether it's from a SaaS service like SAP or Salesforce, if it's a flat file, a CSV, an unstructured file with text, audio, etc. We help you get all that data into Snowflake. We help you to orchestrate the overall process of a data pipeline, and we help you to transform the data leveraging push-down ELT, so pushing the heavy workload of manipulating data down onto the data warehouse, the Snowflakes, Databricks, Redshifts of the world. The way that we do, or the way that we enable developers to build those types of pipelines is via our designer, which I will bring up on the screen in just a moment. At a high level, it is a low-code platform, although you can see there it says high-code friendly. Ultimately, a lot of what I do in Matillion I think of as code optional. I can leverage low-code components to do really simple, repeatable boilerplate work. I can also leverage them to do fairly complex work, or I can write Python or SQL or DBT scripts in order to transform and manipulate data within the Matillion platform as well. So now I'll just give a brief kind of practical, and we'll take a look at a Matillion pipeline here. Still not getting into the AI stuff just yet, but that'll come in just a moment. So this is a Matillion pipeline. You can see here it's called GreenWave Sales Performance, and it's built to take data from Salesforce, from a JSON file that's sitting in S3 bucket, and from a Postgres database, load it all into Snowflake, wait for those loads to complete, and then transform, manipulate the data, and generally get it ready for plugging in your dashboarding tool of choice on the far end. So taking a quick closer look at one of these data loading components here, and the low-code paradigm that Matillion presents, you can see that we can select a data source or a table from Salesforce. This comes populated via dropdown. Then we can also just really quickly select however many columns that we'd like to use for replication. We define some information about the destination, which is Snowflake. What warehouse will we use for the load? What database and schema will the data land into? And what is the table name? After configuring just those few bits, which take me less than a minute, I can hit run on my pipeline, and we're immediately starting to load some data to Snowflake. Now, that's kind of the data loading piece. This entire pipeline you can think of as the orchestration portion of Matillion. You can define things like, what happens if my Salesforce load succeeds, or what happens when it fails. Maybe I want to send an email or a Slack or a Microsoft Teams update to let me know immediately that my pipeline's failed. We have orchestration pieces here like this AND component, which ensures that we wait for all of our loads to complete before we move on to transformations. Now, a Matillion transformation looks much the same as that sort of larger orchestration pipeline that we just saw. Pausing for dramatic effect and for the screen to come back. I got one laugh, come on guys. So Matillion transformations, very similar sort of interface here. We've got a different set of components available. We've got some Snowflake native AI functionality. But in general, and again, just kind of covering some high-level concepts that I'll use as we dive into the AI piece. I start out a Matillion transformation pipeline by plugging in a table input component, which represents a table of data in Snowflake. I can sample that data to take a look at what my columns and rows look like, validate that I have some real data coming from that table. Pausing once again for dramatic effect. I see that the zoom is also screwing around. Sorry about that, guys. Ultimately, what I have here is some components that allow me to really easily do things like maybe flatten some JSON, and this all compiles down to Snowflake SQL. So you can see potentially some time savings here, some productivity gains from just being able to quickly throw together a transformation based on components rather than writing out this longer SQL script yourself. Some people can write SQL faster than they can think. I know a few of those people. And in those cases, as I kind of hinted at earlier, we are code optional. I could just throw a SQL component onto the canvas here and start to do some transformation. All right. Now, with all that boring talk about data integration out of the way, let's talk a little bit about how we're enhancing that capability with artificial intelligence today. So I mentioned we'll cover this in kind of two sections, AI in the product and AI in the pipeline. I'll define AI in the product as artificial intelligence is built and baked directly into the platform to assist with data engineers or business analysts more productively building and maintaining data pipelines. The parts of the platform that support that today are auto documentation, and the real power is our AI Copilot. And that is Matillion Copilot, not Microsoft Copilot. I know we're in the Microsoft building here. I think probably pretty much everyone has a Copilot these days, but just to quickly define that for you. Now, on the auto documentation side, as an engineer, I like to believe that all of my code is self-documenting, but it can be helpful to actually have something that's readable by the business. Maybe I could, if there's someone downstream that's wondering, hey, I have this dashboard, where does the data come from? How does it get created for me? Auto documentation could be a great help to just accelerate that understanding, that literacy in the data that ultimately is consumed. And then on the Copilot side, just as you're probably imagining, let's take some raw text prompts and turn them into data pipelines, and I'll show an example here of exactly how that works. Now, we've kind of covered a Matillion transformation starts out with these components. We've got some table inputs. We do some calculations here. These are effectively some SQL. And at the far end, we'll be writing out a new table on the Snowflake side. Now, what this pipeline is actually doing practically is we're taking some data that comes in from Salesforce, our account data we saw a sample of earlier, and we're taking some data that comes in from a JSON file. And we'll find here that we've got a website, and on the JSON file side, we're going to have some emails. And we're just going to do a really simple sort of text parsing exercise here, where we have these top-level domains. We don't really care about the identifying portion of this email, but this domain can allow us to join to the website domain that comes from our Salesforce data. Now, here's where Copilot comes in handy. If I take away this string function, which I consider myself a fairly competent engineer, I would still need to go look up a function definition, probably just quick Google what is substring in Snowflake, and where do I put the index, and where do I put the column reference. So rather than going down that route and looking up a function definition, etc., with Matillion Copilot, I can just type something like, give me the web domain. Anyone impressed with my one-handed typing skills? From the email address. And Copilot will split out actually a different function than I had before. It's a split part. I believe I had a substring up there before. Sometimes it gives me a regex function. All of the time, it gives me a function that will help me to parse that string. And you can see here I'm now left with this email domain. Now, if you're watching closely, I did skip a step where we parse that JSON. That's just more of the interesting bits of Matillion component-based data engineering here. But it's that Copilot piece that we're here to talk about. Now, that assisted me with effectively generating a little piece of script that assisted in the middle of my pipeline. Another thing that Copilot can do is actually generate entire pipelines itself. So I'm going to open up a new blank transformation here. And by clicking on Matillion Copilot, I can say something instead like, join my accounts table. Let's make sure I can spell correctly one-handed. To my orders table. So we've got some orders. We had that sales performance pipeline that we were talking about earlier. And by entering that, just raw natural language text, Matillion's going to take some time processing this. If it slows down, I'll flip to my pre-saved configuration of this that I did earlier, but it looks like it's moving along nicely. And you can see exactly how the AI is kind of thinking about things. It's looking at some of the earlier pipelines, it's searching for some tables. It found my accounts and orders table. Now it's deciding what Matillion loco components should it use in order to execute this join. Eventually it's going to ask me, or tell me what it's going to try to do, and ask me if that sounds good or if I need to further refine my prompt. And you can see here exactly that. We have a plan. It'll tell you its assumptions, its references, where it kind of found the information that's going to eventually feed the pipeline. And I can say, yes, proceed with that, and it'll throw some components onto the canvas here. So all of this effectively has been AI in the product. Artificial intelligence to accelerate how I, as a Matillion developer, would naturally go about building data pipelines. I'm going to pause there while the AI is also pausing, and just take a moment, see if anybody has any questions, wants to shout out here. Yeah, go ahead. Yes. The question was, are you using a self-hosted LLM for the brains behind? And yes, we are. Did you have a follow-up? Proprietary, yep. Ultimately trained on Snowflake and Matillion documentation. And I should say, and product and security will be happy with me for saying this, not trained on customer data. So you can see maybe, hopefully, my internet connection here. But I'm just going to leave this behind and show you that eventually Copilot will spit out a very simple transformation for me. We can inspect the SQL and see that we're doing a select from a few different tables, joining on them, and I can take a sample of the data to double check if this works how I wanted it to as well. So that's been AI in the product. Now AI in the pipeline. So more than just plainly accelerating the productivity of people working in Matillion, we want to enable the data public, data engineers, data analysts, et cetera, to leverage artificial intelligence to enhance their analysis. We do this with a few different types of components. AI prompt components. I wonder if this zoom in will work very well. Yep. As you can see here, we have things like OpenAI prompt, Amazon Bedrock prompt, Azure OpenAI prompt, Snowpark Container Services prompt. These are just different LLM integration points that allow us to take data that's sitting in Snowflake, maybe some raw text reviews of a business, and process them with an LLM with a prompt and get all of that data analysis back in Snowflake, all with a single component. We also have the ability to use retrieval augmented generation, RAG, to enhance the capabilities of those LLMs. So Matillion can, first of all, help you to chunk data, populate a vector store, and then when you're actually going through and executing against one of these prompt components, you can leverage that, the RAG that you've built with the sort of vector store you've populated with Matillion. We also have things like unstructured data components, so components that help you to process audio, raw text, images, and being tightly integrated with Snowflake, as we also are with Databricks, Redshift, Synapse, as I mentioned before. We will have some platform native AI capabilities that we can leverage as well. So on the Snowflake side, that's going to be Snowflake Cortex, which the way that we leverage it effectively is Snowflake exposes a SQL API to access Cortex functions to take advantage of the Cortex LLM. So kind of just touching all of this, I'll move through these next couple slides very quickly. We've got our prompt components. I'll show you a practical example of how to use one of those in a moment here. At a high level, the use cases for this are fairly endless, but we can do things like summarize data, classify it, do some PII detection, sentiment analysis, all of these things taking data that's stored in Snowflake, processing them with an LLM engine, storing the data back in Snowflake again. So let's take a closer look at the Azure OpenAI prompt component here. So what I start off with is basically some raw text reviews that customers have left at a popular barista company that you may have bought some coffee at for lunch today. That data is stored in Snowflake, and we're going to use Azure OpenAI to process it. So you can see here I first set up some connection information. I have an API key. I can choose some temperature and top P, which just influences some of the responses that the LLM will give us. I plug in, here's my source table in Snowflake. It's called Stage Barista Reviews. It has a key column called name. And then I can get into the actual prompt engineering portion. Sharing on Zoom. So, prompt engineering. I've pointed the component at a Snowflake table. Now I'm going to add some context for the LLM. You're a marketing analyst reviewing user comments for a well-known barista company. I define some inputs. Five, 10 more minutes, all right. I've got some inputs. I identify some columns in Snowflake as well as just some descriptive names. These are effectively defining these as proper nouns, the Zoom. We have some inputs, ... And we can define some outputs. So this is what I want the LLM to tell me. How upset are my customers? Will they return? Are they cussing at us? Are there swear words in there? And then I define, finally, as we saw in our load component earlier, a destination table in Snowflake. And after configuring all of this, optionally enabling RAG and adding some more context for the LLM as it deciphers these raw text reviews for not Starbucks. This component will do that. Now, let's take a zoomed in look at the Cortex Snowflake integration portion of this. So we've talked a little bit about just the LLM prompt components. Snowflake has some bespoke integrations that they built as well on their Cortex LLM. And what we're going to do here is I have a table of data that if we inspect is just a fixed flow that I've defined where I throw in a bunch of PHI information. Here's my birthday, I have arthritis, here's my home address, and my name. And leveraging the Cortex completions function, which allows me to select a model, give it a prompt, you're a compliance analyst, tell me if there's PHI data, and ultimately this component, when I sample, will tell me exactly that there's some PHI data and that we might want to mask that before publishing this data to our downstream consumers. Now, with that time check that I got just a moment ago, I think I'm just going to pause there, see if there are any lingering questions. Just kind of as a recap, Matillion is an end-to-end data engineering platform purpose-built for the cloud and for cloud data warehouses like Snowflake. We have AI in the product to accelerate you building pipelines and AI in the pipelines to allow you to use LLMs as you analyze data. Question? I believe the question was, how do you handle input and output max token events with large language models? I don't have an answer for that. If you reach out to me on LinkedIn, though, and you are curious, I'm happy to give you an answer offline. Great. I have more minutes. Do we have more questions? Please. question. Great. Are there any challenges that we've seen with our users adopting the AI portions of the product? Yes, I would say there have been some. I'd say it's not uncommon for teams to come to speak to Matillion that are very interested because they've seen some of the AI stuff we've been putting out into the market, and then say, hey, my boss told me I need to start leveraging AI. I'm not really sure, what that means or how I should use it, and then maybe needing a little bit of education on top of it. I think that's a really common issue that we see. Also, developers that are used to working in code and writing everything themselves, maybe slow to adopt and trust AI to fuel some of the pipeline building. I think that friction falls away pretty quickly once you start to experiment and see the power of it. But yeah, it's just a couple things off the top of my head. Any follow-up there? Cool. Yep, back there. Yeah. Yeah, that's a great question. So I think the question was basically if you have a really complex SQL statement or just SQL statement, right, that you're trying to use, can Matillion be used to disambiguate it, make it business readable and understandable without parsing through the code? Is that right? Yep. So I think I had probably mentioned it on a slide and then failed to show it on the screen so far, but if I, for example, select a few components here, one-handed, yep. So if I select a few components here and then right-click, I can click to add a note using AI, and this, I believe, is the answer to your question. AI will then sort of disambiguate what's been happening in this pipeline and help to make it human readable and understandable. Are there limitations to it? Yep, I would say nothing immediately comes to mind as far as a limitation. I'm sure there are some, but yeah, when I've been using this, it's been pretty powerful, I would say. Mm-hmm. Back there. Mm-hmm. So the question was, AI can hallucinate. Do we do anything to try to prevent and manage hallucinations or just incorrect answers generated? Yes, we do. I cannot elaborate. Is there maybe someone back there? Okay. Anybody else? Questions? Alrighty. How much time do I have left? 10 more minutes if I need? Okay. Then I'm trying. I'm trying so hard to share. Nope. It could be a cord thing, yeah. I think it might be a little late to switch out the cord, but maybe for the next person we should try that. I have an extra dongle. So just to, I guess, continue to expand upon what Matillion can handle. And sorry for the zoom stuff on the screen there. We've seen text parsing. I won't actually show this in the platform, but Matillion can assist with things like OCR, taking PDFs or images, turning them into structured data that we can actually use and do analysis on with SQL. And we offer this sort of functionality through further integrations with external platforms. So you'll see things like Azure Document Intelligence, Amazon Textract, Amazon Transcribe, Azure Speech. These are all effectively native platform integrations that look and feel a lot like what we saw with the LLM component. They allow you to pass data through those platforms, get responses back, and store it in Snowflake all in an automated fashion. And that actually, I don't need to take 10 more minutes. That has brought me to the end of my prepared material. Do we have the winner yet, Alex? Or ooh, somebody gets a jersey. Any final questions while we get our next speaker up here? I cannot answer that. But I'm happy to, as I mentioned earlier, if you want to reach out on LinkedIn, I have some great contacts in the Matillion product team that I can ask, why did we decide to use RAG? What would be the alternative? Got it. I'm not the authority there, but I think it's an important question, and again, happy to follow up later.
Thank you very much. All right, demo gods, listen. We're going to say one prayer to you that you've gotten your sacrifices for tonight. You got plenty from Angus, plenty from me. So excited to be here with everybody. I'm Chris Latimer. I'm one of the co-founders of Vectorize. Before that, I spent about 25 years in this industry, ranging from lots of time as a developer, a enterprise architect. Ended up over at Google, where we were building out API management software in the cloud. And then finally over to Vector Database, and that's where, or DataStax, where we were focused on vector databases. And so I ended up spending about 2+ years there and another year here at Vectorize, just working with people on all of their AI applications, helping them get their data right. And in that time, we got a chance to see a lot of different applications, all the things that could go wrong when you're building AI agents. So I've got really 3 goals for today's session. The first thing is I want to just talk about how agents are supposed to work. What's the theory? How are these things, in practice? What's the brochure say for an agent? And then what's going to happen in practice? So when you get into the real world, things are not always going to work the way that you want. So what can you expect to encounter along the way? And then we'll talk about how we can kind of bring those things together and what are some coping mechanisms that you can have as you're building out agents to hopefully make them work better and support the use cases that you're trying to implement. So let's level set first by what do we actually mean by an agent, because there's a lot of definitions out there, and there's really no barrier to entry to somebody calling things an agent. Almost everybody will say, oh, we're doing AI agents wherever you go. So when I talk about agents here, I'm really looking at a few things specifically. I'm talking about things that have agency. And so the AI is going not just to be a workflow where we happen to call an LLM on some of those steps, but we actually want it to make decisions for us about how to implement whatever the goal is that we're asking it to accomplish. In addition to that, we want to give the LLM and the agent some way of interacting with this environment. If you guys are working in enterprises, a lot of times this is going to mean some form of interacting with data or APIs to accomplish things. And we don't really want to be the brains behind this operation. We don't want to build out software that says do this, then do this, then do this. We want the agent to really figure that stuff out for us. And that's the promise of agents. And really when we think about how to build these out, I always like to think in terms of the architecture first. So what are the layers of the architecture that we might want to think about? And so I usually think about it in these terms. At the bottom, there's this reasoning layer. This is the brains of your agent. This is what is going to decide based on what you give it, how it's going to go about orchestrating the right tools in the right order to accomplish whatever goal it is that you've set out for the agent to deliver. And then at the top, you have your tool layer. So these are all the things that you have in your environment. These are all your APIs. These are your databases. This is the business logic that you've built. And then in between those two things, there's this action or this orchestration layer where the LLM doesn't actually have the ability within it to make an API call. It doesn't actually have the ability within it to query your database. So you, as this action orchestration layer, is kind of where you spend your time, which is kind of brokering back and forth between the LLM telling you to do something and you actually doing it and then handing back the results to the LLM. And at the heart, this really is the agentic system architecture. This is what we're building almost every time we go out to create an agent. And usually where most people start is they're like, great, LLM, here's a really complex task, and here's a bunch of functions. Here's everything that you would need to use. And the LLM, of course, is always going to happily reply back to you, like, yes, of course, I'll get right on that, and mission accomplished, boss. I did what you want, right? And then you look at it, and a lot of times it's pretty optimistic about what it was able to accomplish. And if you've been paying attention for the last 2 weeks, you might be thinking, wait, I just put an MCP server around this, and this is going to solve everything. But MCP doesn't actually solve that problem for us. It just gives us a nice way of kind of wrapping all those functions together. And nothing against MCP. It's a great, nobody has reinvented service discovery for the last like 5 minutes, so we were overdue. Okay, so where do things go wrong as we're building out agents? So really 3 main places, like main candidates to keep an eye on. The first is really around data access, because that tool layer, whether it's data retrieval functions, whether it's APIs, whether it's going and doing SQL queries. The LLM, if it doesn't have the right data, it's hamstrung. It's not going to be able to accomplish what it is that you want it to accomplish. And then likewise, we actually have to package that into mechanisms for the LLM to be able to use. And if you haven't aligned your task definition, what you want the agent to accomplish, to the functions that you're giving it, the LLM will have trouble figuring out exactly how to retrieve the data that you want it to retrieve. So data access is going to be very important. And likewise, if we kind of think back to that last slide where it's like, hey, LLM, here's a whole bunch of stuff in a complex task, that's basically this agent monolith. It's the same problem we've been grappling with for a long time as software developers, as software engineers, is that we need to think about how to logically organize our software. And LLMs don't get us out of that business. We still have to do some thinking around how to package up our software in a way that is going to work the way that we want it to work. And so if you start off by saying, here's a really complex task, here's a bunch of functions, your results will be fairly predictably bad. So we want to have some way of thinking about how do we deconstruct this. We'll talk about this coming up. And then closely related to that is this idea of prompting. The longer, I think we had a question earlier about RAG and about, sort of the usually part of the sort of thought process behind that question is, well, I'm going to get these really, really big context windows. And I can just throw everything that I need in there. And it's sort of one of these things where you stop and think about it and say, well, wait a minute. That is like such a bad idea in every other context. If I told you, hey, I just got this new MacBook Pro and it's got 32 gigs of RAM on it, you wouldn't say, well, let me not query just the data I need and hand it back on my application. You always want to get sort of a fast retrieval. You want to have just the data you need and get it into your application. LLMs are really no different. Just because we have these really big context windows doesn't mean we just want to have these really, really big prompts and throw all the data in the world at it and hope it figures it out. Because generally speaking, that's also not going to work particularly well. So thinking about how we can constrain the problem, simplify our prompt, simplify the data that the LLM needs to make sense of, and then have the LLM figure out what to do with that data is going to generally give you a lot better results than if you say, here's all of my Google Drive, figure things out. So let's start off by talking a little bit about this idea of decomposing agent monoliths. And so in a way, you can think of this just as a good software development practice. The same sort of thing we've been thinking about for a long time, starting back with the Unix philosophy of building software. Make each agent do one thing well. Assume that when I get the output of one agent, that's going to be the input to another agent. And we need to build these things in such a way that they're made to work together and create bigger, more complex pieces of functionality. And so the same practices that we've been thinking about for a long time still hold true in the agent world, and will still help you create software that's going to be more maintainable, more easily testable. And I don't see any disadvantages of doing this, honestly. When you think about, this isn't necessarily microservices where we're going to split this out and say, now let's deploy each one of these agents as an independent unit. Then there would be some disadvantages in terms of operational complexity. And there might be some disadvantages if you decide, I'm going to take on a framework, which is always a bit of a trade-off anyway, because you're going to have framework complexity, you're going to be dependent on the framework, and the trade-off is sometimes you get a little productivity benefit. If you do that, up to you. And some frameworks like CrewAI, things like Swarm from OpenAI, all that they don't promote that as a production-grade solution, will give you some of these capabilities out of the box. Likewise, on the data access patterns, really thinking through where your capabilities are in your organization. Most enterprises are going to have really strong, structured data maturity. They're going to have things that they built over the past couple decades, API programs, RESTful APIs, GraphQL. When you start to get into the unstructured side of things, usually it's a little bit less mature. People are kind of figuring things out a bit. Should we use RAG? I used RAG, I didn't get very good results. Like, what's going on? And I don't know why that happened. When you're working with agents, thinking about this whole process of how do you get not just semantic search, not just sort of like the pieces of your documents that you need, but really thinking through what are the access patterns that I need, how do I build metadata, how do I let the LLM narrow down the search criteria to get just the pieces that it needs, is going to serve you very well. And we're going to take a look at how we do that coming up here really shortly. Now, most of the time, when we think about that unstructured data processing, we start to think about what are called RAG pipelines. And generally, this is just saying, how do I take my unstructured data? That may be documents. That may be things that live in your knowledge bases. It might be sort of the unstructured part of a SaaS. If you're using, like, for example, Salesforce, you have meeting notes in there, along with your structured data about your contacts and opportunities and things. So how do you take that unstructured data and make that as easily accessible as your structured data in the organization? That's really the ultimate goal of your RAG pipeline, is to figure out how do I do that ETL process so that I get the content, but I also get really well-structured metadata. And in order for us to be able to support agentic use cases, we really need to have a clear picture of that metadata and how we're going to be filtering how we want the LLM to be able to retrieve that data. And that's really the main difference here between what I would call vanilla RAG, naive RAG, and agentic RAG, is that we want the LLM to be able to understand the data access patterns that it has access to. And so the more descriptive we can be, both in terms of the functions that we pass into the LLM, as well as the parameters that it's going to pass in, the better job the LLM is going to do. So what I mean by that is, a lot of times you'll say, well, I've got this really complex metadata model, and I'm just going to hand the LLM the entire metadata model. You figure it out, LLM. And in general, the less you say you figure it out, LLM, like the better off you're going to be in most of the time. So we'll take a look at how we kind of put all of this together.